Hello everyone, welcome to Genius Tutorial. So today in this session we are going to discuss few more questions for Pgdba 2020 and we will follow this trend in our coming sessions to come up with more new questions for Pgdba 2020 series. But before we are going to start with today's session, you must subscribe to our YouTube channel if you have not subscribed it yet, and the rest of the details you can get from the description given below. Okay. So without wasting any time, let's start with today's session. So this is question from limits topic. What I suggest you that you just pause this video and try this question on your own so that we can start with it. Okay, so before going to start with this question, let me tell you one result that limit x approaches to 0, 1 plus fx raised to the power 1 by gx. Whenever we get this type of expression and a required condition is that limit x approaches to 0 fx, this should be equal to limit x approaches to 0 gx, and this should be equal to 0. Okay, so if this is the condition, then we can say that this is equal to e to the power limit x approaches 0 fx upon gx. So now to change this given expression in this form, we have to add 1 in this bracket and subtract 1 in this. So this way we can say that fx is equal to this 1 to the power x plus 2 to the power x plus 3 to the power x, so on up to n to the power x upon n minus 1. This will be the value of fx. So now this is fx and gx will be x by a. Now if you see that limit x approaches to 0 for both this expression, this will give us 0 value. That means the conditions are satisfied. So we can rewrite this expression as e to the power limit x approaches to 0 and this can be written as 1 to the power x plus 2 to the power x, so on up to n to the power x minus n divided by n, and this divided by gx, that means into a by x. So that will be e to the power limit x approaches 0 1 to the power x minus 1 by n plus 2 to the power x minus 1 by n. You do one thing, you write x here, we will take n outside, so on up to n to the power x minus 1 by x, and this is a by n here. Okay, now we know that this formula will be it will be limit x approaches to 0 e to the, okay, a by n we can write here because it is independent of x. So it will be 1 to the power x minus 1 by x, 2 to the power x minus 1 by x, so on up to n to the power x minus 1 by x, and this will be nothing but a by n. This will be log 1 plus log 2 plus log 3, so on up to log n. Okay, and this will be e to the power a by n into log of product of all this 1, 2, 3, so on up to n. This will be n factorial, or we can say it would be e to the power log n factorial raised to the power a by n. And if e to the power log this, so we can say that this will be n factorial raised to the power a by n. This is our final answer to this question. So correct answer will be this option A. Okay. Okay, let's move on to next question. Okay, next question is if a plus b plus c is equal to 0, then this equation 3ax square plus 2bx plus c equal to 0 has, okay, this is very important type of question. And okay, before going to start this question, pause this video and try this question. Okay, so for these type of questions, what we have to do here, you have to consider a function. Let us consider function fx as ax cube plus bx square plus cx. Basically, we have to consider a function fx such that its derivative is this. Okay, we know that derivative of this function is 3ax square plus 2bx plus c. So now this is a polynomial function, so obviously this will be a differentiable function and continuous function. So two conditions are satisfied. A rest is if in this interval 0, 1, what will be the value of f of 0? That will be 0. And value of f of 1, it would be a plus b plus c, which is also given as 0. So that means third condition, f of 0 is equal to f of 1. So all the three conditions of Rolle's theorem are satisfied here. That means, according to Rolle's theorem, fx has at least one root in this interval 0, 1. Okay, because you know this, no? That if all these conditions are satisfied, then f dash x will be equal to f dash c will be equal to 0. Okay, or you can say one root lies between this interval. Okay, so correct answer to this question is option A. Let's move on to the next question. The function f defined from this to this, and fx is e to the power x cube minus 3x plus 2, and you have to tell that whether this function is 1, 1, onto, into, or many 1. Okay, pause this video and try this question. Yes, now in this question, fx is e to the power x cube minus 3x plus 2. Okay, let us consider this as hx. Here hx is x cube minus 3x plus 2. So h dash x that will be 3x square minus 3, or you can say 3 into x square minus 1. That means h dash x will be greater than or equal to 0 whenever x belongs to minus infinity to 1. Okay, so this implies that fx will be an increasing function. Okay, if fx is an increasing function, this implies that fx is 1, 1. We know that a function is whenever a function is monotonic, whether it is increasing or decreasing, that function will be a 1, 1 function. Now let us see range of fx. Range of fx will be if I substitute, okay, range of fx will be 0 to e to the power 4, because when I substitute x is equal to minus 1, we will get 4, and I guess that will be the maximum value in that power. So range will be 0 to e to the power 4, and this will be closed. But codomain here is 0 to e to the power 5. Now range is not equal to codomain, and whenever range is not equal to codomain, so that means the function is not onto function. Condition for onto function is that range should be equal to domain, but in this case range is not equal to codomain, so the function is not onto. So correct answer to this question will be option D. Okay, so D option, this should be your correct answer. The function is 1, 1 but into. Okay, I hope you enjoyed the session. Let's do this much for today, and we will come up with next session soon. So do subscribe to our YouTube channel if you have not subscribed it yet for coming videos. Okay, thank you so much.